A single chili pod, dried and cracked open under a magnifying lens, releases a compound so potent that 0.5 milligram of it can raise your body's core temperature. And Aztec healers were harnessing that exact reaction over 500 years before a single laboratory ever measured it. That compound is capsaicin, and it is only one soldier in an army of 9. For most of human history, fat-burning food was not a marketing phrase. It was survival math. In the high highlands of Ethiopia, coffee cherries were chewed whole by warriors before long marches, not for flavor, but because the caffeine inside sharpened focus and measurably increased the number of calories the body burned at rest. In coastal China, green tea leaves were steeped by Buddhist monks who noticed, centuries before anyone could explain why, that the drink kept them alert through hours of fasting meditation without the crash of other stimulants. In the Andes, quinoa and almonds, protein-dense, slow-digesting, were staples precisely because they kept farmers working through entire days on very little food. None of these cultures had the word thermogenesis, but they had observed, repeated, and passed down something real. Certain foods cost the body more energy to process than others, and certain compounds nudge metabolism upward in ways that are measurable, not mythical. That is the actual science behind fat-burning snacks. Not magic, not instant transformation, but a set of well-documented metabolic effects that, when stacked together intelligently, add up to something worth understanding. Here is the first thing that will surprise you. Protein itself is metabolically expensive. Digesting and processing protein burns roughly 20 to 30% of the calories contained in that protein, just in the act of breaking it down. Carbohydrates cost 5 to 10%. Fat costs almost nothing to digest, under 3%. That means a handful of almonds and a spoonful of peanut butter are not just healthy snacks. They are metabolically active foods, working against themselves in a way that softer, fattier snacks simply do not. That single fact rearranges how you should think about a snack drawer. To understand why these 9 snacks work, you have to understand where their active compounds actually come from, and the growing conditions behind them are far more specific than most people realize. Capsaicin-rich chili peppers. The compound behind several of tonight's snacks reach peak potency when grown in hot, dry climates with well-drained, slightly acidic soil. A pH between 6.0 and 6.8 is considered ideal. The peppers are harvested by hand at full color maturity, typically 70 to 90 days after transplanting, because capsaicin concentration continues rising until the fruit is fully ripe. A pepper picked green, before that ripening window closes, contains a fraction of the compound found in one, left to redden fully on the plant. After harvest, the pods are either dried slowly in low humidity to preserve capsaicinoid content or processed immediately, since heat and moisture degrade the compound over time. Commercial operations dry at scale in mechanical dehydrators. Small growers still sun-dry on mesh racks, a method that, ironically, often preserves more of the compound because the temperature stays lower and more controlled. Green tea. The Camellia sinensis plant is harvested in flushes. The first flush in early spring produces leaves with the highest concentration of catechins, the antioxidant compounds responsible for its modest metabolic boost. Growers in regions like Uji, Japan, and Fujian, China, pick only the top 2 leaves and a bud from each stem, by hand, because mechanical harvesting damages the leaf structure and reduces catechin retention. The leaves are then steamed or pan-fired within hours of picking to halt oxidation, the single step that separates green tea from black tea, and the reason green tea retains far more of its metabolism-supporting compounds. Researchers at Maastricht University in the Netherlands have spent over a decade studying exactly this kind of compound behavior. Their research on capsaicin and catechins found that these substances can modestly increase daily energy expenditure and fat oxidation, not through some dramatic instant effect, but through a small, consistent nudge, meal after meal, that compounds over weeks. That word, compounds, is doing a lot of work in that sentence, and it should, because here is the moment that changes how you'll think about every fat-burning claim you see online. There is no single snack, no single compound, and no single pill that creates a large metabolic shift in isolation. What the research actually shows, again and again, is that small, repeated thermogenic nudges from protein, from capsaicin, from catechins, from fiber slowing digestion, stack on top of each other across a day and across weeks into something measurable. That reframes the entire premise of tonight's list. You are not looking for 9 magic foods. You are looking for 9 tools that, used together, tilt your body's daily energy math slightly in your favor, hundreds of times, meal after meal. Number 1. Almond carry the highest thermic protein cost of any tree nut per calorie, alongside fiber that slows gastric emptying, meaning you feel full longer on fewer total calories, a finding repeatedly confirmed in satiety research out of Purdue University's Nutrition Science Department. Number 2. Greek yogurt. Greek yogurt, strained to remove whey, concentrates protein to nearly double that of regular yogurt, triggering the same elevated thermic effect, while delivering calcium, shown in multiple studies, to support fat metabolism regulation. Number 3. Cayenne-dusted popcorn. Cayenne-dusted popcorn combines 2 mechanisms in one snack. The fiber-rich whole grain slows digestion, while the capsaicin from cayenne activates the same heat-sensing receptors, called TRPV1, that give chili its metabolic nudge. Number 4. Hard-boiled eggs, eaten with green tea, pair complete protein with catechins, a combination studied specifically because protein and catechins appear to have an additive, not just parallel, effect on energy expenditure. Number 5. Edamame. Edamame delivers plant protein alongside fiber and isoflavones. Compounds a study published in the Journal of Nutrition linked to modestly improved fat oxidation during light activity. Number 6. Grapefruit. Grapefruit, eaten whole rather than juiced, retains a compound called naringenin, which early research suggests may influence how the liver processes fats, though scientists are clear this effect is modest, not miraculous. Number 7. Apple cider vinegar. Apple cider vinegar, taken diluted before a meal, has been shown in multiple small trials to blunt the blood sugar spike that follows carbohydrate-heavy food, a slower glucose curve that reduces the insulin spike associated with fat storage signaling. Number 8. Cottage cheese. Cottage cheese shares almonds' high thermic protein cost but adds casein, a slow-digesting protein that extends satiety for hours, which is precisely why it has quietly become a staple in sports nutrition research on appetite control. Number 9. Dark chocolate. Dark chocolate, above 70% cacao, contains flavonols, shown in cardiovascular research, to modestly improve how the body metabolizes fat during exercise. Proof that even something that tastes like indulgence can carry a real metabolic signature. None of these 9 foods, alone, will kill fat instantly. That phrase does not describe biology. No food does. What they share is a measurable metabolic cost, or a measurable hormonal effect. And the research is consistent that the people who benefit most are not the ones eating one magic snack, but the ones who replace low-protein, low-fiber snacking with these higher-cost, higher satiety alternatives, day after day, for months. In traditional Ethiopian and Yemeni highland communities, coffee was never a beverage separate from work. It was consumed specifically before physical labor, timed deliberately, because generations of observation had shown it sharpened endurance. In Sichuan province, chili peppers were bred and selected over centuries, not just for flavor, but for exactly the heat intensity that modern researchers now measure in Scoville units and correlate with thermogenic response. This is not folklore dressed up as science. This is generations of careful, repeated observation arriving, independently, at conclusions modern metabolic research would later confirm with instruments these communities never had. Here is something you can do with this today. Pick one snack from tonight's 9, a handful of raw almonds, or plain Greek yogurt with a few berries, and place it where your current snack normally sits for the next 7 days. Not all 9. One swap, repeated daily, is the exact mechanism the research points to. Small, compounding change, not instant transformation.